All right, our objective today is to write a polynomial function given a context, as well as to be able to write a function in terms of another. So let's take a look at example 1. Express the area of an equilateral triangle as a function of its perimeter. So think about when you see something like f of x, what that means is your polynomial f as a function of x, so x squared plus 3. If you see f of 3, we have our polynomial f is a function of 3, so 3 squared plus 3, etc. So when we see a problem like this, where it says express the area of an equilateral triangle as a function of its perimeter, that means that we want to write the area as a function of the perimeter. So ultimately our end goal is to get our perimeter to be our variable. So our goal is to find area in terms of the perimeter. So we're going to use the area formula. Area of an equilateral triangle is side squared, square root 3 over 4. That's a simplified version that you may or may not have known prior to this class. But if not, write it down, memorize it, now you know. Perimeter of an equilateral triangle would just be 3s, because if it's an equilateral triangle, all sides are going to be congruent. So we are going to take out the variable s, because right now area is a function of the side length, and we're going to replace it with p, so that we can have area in terms of the perimeter. So if we take a look at those two equations, both equations have s in it. So if I take my perimeter equation, solve it for s, I'll then be able to substitute it in. So I take my perimeter equation, p equals 3s, solve for s, we get s equals p over 3. So I now take that and I'm going to substitute it into my area formula. So I get area as a function of the perimeter is equal to, take out side squared, square root 3 over 4, and we're going to put in what we solve for s for the p over 3. And now let's simplify this equation. So that ends up giving us p squared over 9 times the square root of 3 over 4, and we don't like a fraction over a fraction, so that's p squared square root 3 over 36. Because when you divide by 4, it's the same thing as multiplying by 1/4. So our final answer, area as a function of perimeter, is p squared square root 3 over 36. And p over 3 squared is p squared over 9, because p over 3 times p over 3 gives us p squared over 9. So that's our first example. Our second example, write the circumference of a circle as a function of its area. So our goal is to find the circumference in terms of the area. So our two formulas, circumference is 2 pi r, and our area is pi r squared. So we want circumference as a function of area. So I want to take out r and put in A. So if we take a look at my area formula, I'm going to take that equation, I'm going to solve it for R, so I can then substitute out R and put in A. So we get R squared equals, oh, I don't know how to undo that. Okay, R squared equals A over pi. We're going to take the square root of that. We get R equals the square root of A over pi. I don't need plus or minus because we're talking about area circumference. That's always going to be positive. So now I'm going to take that radius and I'm going to substitute it into the circumference formula. So I get circumference equals 2 pi r, but we're going to take out r and now substitute in the square root of a over pi. So that's about as simplified as that gets. I can't simplify the pi and the pi because this is pi and that one's square root of pi. All right, next example. A trapezoid has a smaller base that is twice the length of the height. The larger base is 3 times the length of the smaller base. Express the height of the trapezoid as a function of its area. So now we want to say that we want to get the height as a function of the area. So our goal is to find h in terms of a. So we're going to use our trapezoid formula, which if you don't know this one ahead of time, again, know it now, memorize it. So the area of a trapezoid is 1/2 height times the quantity base 1 plus base 2. So we want the height in terms of the area. So I'm going to get rid of B1, B2, and I'm going to replace them with h so that h and a are our only variables. So to make this question a little bit easier, I think drawing a picture is going to be helpful. So we have a trapezoid has a smaller base that's twice the length of its height. So that's 2h. The larger base is 3 times the length of the smaller base. So 3 times the length of the smaller base, which is really 6h. Express the height of a trapezoid as a function of its area. So now I'm going to take my area equation and I'm going to substitute out B1, B2, substitute in 2h and 6h because this is our B1 and this is our B2. The two bases of our trapezoid. So now we're going to simplify this. So we get area is 1/2 h times 2h plus 6h is 8h. When I multiply that together, I get 4h squared. And now, right now, I have area as a function of the height, but I want the opposite. I want the height as a function of the area. So I'm going to have to solve for h. So divide both sides by 4. We get a over 4 equals h squared. Now square root both sides, so we get h equals the square root of a over 2. Because when you square root both sides, square root of h squared is just h. Square root of a over 4 is square root of a over 2, because square root of 4 is 2. So to write our answer formally, we have h of a, so our height as a function of the area is equal to the square root of a over 2. All right, so our last example, write the radius of a sphere as a function of its volume. So we want the radius as a function of the volume. So our goal is to find the radius in terms of the volume. So we're going to need that volume formula. So the volume of a sphere is 4/3 pi r cubed. Again, if you did not know that, know it now, memorize it. So volume equals 4/3 pi r cubed. So I want to write now r in terms of v. So this one is pretty straightforward since I have both r and v and they're the only variables we have. All we're really going to do here is just solve for r. So I have v equals 4/3 pi r cubed. So I'm going to multiply by the reciprocal. So we get 3v over 4 equals pi r cubed. Divide both sides by pi, so we get 3v over 4 pi equals r cubed. And now I'm going to take the cubed root. So I get r equals the cubed root of 3v over 4 pi. So our radius as a function of the volume is the cubed root of 3v over 4 pi. All right, that's our lesson for today. The main goal is to keep in mind what you're trying to write each function of and solve for the appropriate variable. At this time, you can show Mrs. Black your notes, and you have the rest of the period to work on your homework. You can also ask Mrs. Black for questions. She knows math pretty well, and she'll hopefully be able to help you guys out. All right? I will see you all Monday. Have a great weekend.